quadratic equation, and it has to be in this form, in standard form, to put into the quadratic formula.
3x squared equals 6x minus 9 is not in standard form. So in order to put it in standard form, you have to add 9 and subtract 6 and bring it to the other side in order so it'll equal 0. And 3x squared minus 6x plus 9 equals 0 is in standard form. And that's how you need to have it in order to put it in the quadratic formula.
Okay, and when you have it in standard form like this, you can get what A and B and C equals, and A equals 3, and B is -6, and C is 9.
And then the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So b would be -6 plus or minus, and then -6 parentheses the square 2 squared minus 4a, which is 3, c, which is 9, over 2a, which is 2 times 3.
Because d equals b squared minus 4ac. And this is an example from page 50 in the book, all these are. So it's x squared plus 4x minus 1 equals 0. D equals 4 squared minus 4 times 1 times negative 1 equals 20. And when you finish, you should get 20 is greater than 0, which has two distinct real solutions. Number 2, another type is this one. 4x squared minus 12x plus 9 equals 0. D equals negative 12 squared minus 12 squared times negative 4 times 4 times 9 equals 0, which has one distinct real solution. And the last example is 1/3 x squared minus 2x squared plus 4 equals 0, which is negative 2 squared minus 4 times 1/3 times 4 equals 4 over 3, which is less than 0, which has no distinct real solution.
I'm about to explain about the quadratic formula. The formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. This is my example. 3x squared minus 5x minus 1 equals 0. It has to be in standard form. Luckily this one is, to do all the steps you need to do to get your answer, get the roots. Next, you need to pull out a, b, and c. A would equal 3 from right here. B would equal -5. And c would equal -1. Next, you would plug it in. So x equals -5 into parentheses with a negative outside of the parentheses, plus or minus the square root of -5 squared minus 4 times 3 times -1, all over 2 times 3. Next step, you would do x equals 5 plus or minus the square root of 25 plus 12, all over 6. Okay. Next, we would do x equals 5 plus the square root of 37, all over 6. Or x equals 5 minus the square root of 37, all over 6. We have to break apart the plus and the minus. Alright, you would solve that using your calculator. You would do 5 plus the square root of 37. Do that first, and then you would divide it by 6. And for this one, you would do 5 minus the square root of 37, and then divide it by 6. Then you get your roots. For your additional one, your root would be x equals 1.847, or x equals -1.80 for your subtraction.
Alright, so quadratic curving. In quadratic curving, you're going to graph the solutions that you can get from your quadratic equation, if there are any solutions. So, in this problem, you can see that we have two real solutions. X equals 1.847, or x equals -0.180. Now, when you graph it, you must set up your vertex points. In other words, your window. Alright, so for my scale, I put 1 because I'm counting by ones. For my minimum, I put -3 because that is all I need in order to graph these. For my max, I need 3 as well because, again, that's all I need. Anyways, you're going to graph them on the board. From here you can see 1.847 is right here and -0.180 is right here. Alright, so when you do quadratic curving, you're going to need to draw a curved line symbolizing your solutions. So once you do this, you have your solutions graphed onto the coordinate plane. This is quadratic curving.